Hello everyone, my name is Michael Cook, and this is some work that I did with my colleagues Jeremy Gao and Simon Colton on a piece of software called Danesh. I'm really sorry that I can't be there today to give the talk in person. There were some unforeseen circumstances that kept me at home and from traveling, unfortunately. But I've made this recording, so there won't be any technical issues, hopefully, and you've obviously got the paper that you can look at for the in-depth story afterwards. The paper's called Towards the Automatic Optimization of Procedural Content Generators. So I'm going to be talking about some specific results that we got from the tool, but also talking more broadly about the tool itself. I should point out, myself and Simon Colton work at the Metamakers Institute in Falmouth University, where all of this work was done. And we also had some excellent assistance from Jeremy Gao, our colleague at Goldsmiths in the University of London. So I'm going to give you an introduction to Danesh. We're going to actually walk through the user interface as well, so you get a feel for what it does. I don't want to dwell too much on the fine details of algorithms and equations and stuff in this talk because you've got the paper for that. So instead I want to motivate you about this tool and hopefully make it interesting to you and maybe something that you want to go and look at after the talk yourself. I will mention the experiments that we did on automatic optimization and what automatic optimization even means in this context. And we'll look at some of the results and what they might mean and the kinds of objectives that we got in the future. I wanted to begin by telling you the motivations for building Danesh in the first place. So I think that there are certain problems with procedural content generation right now. Not everyone will agree with me, don't worry about it if you don't. But I feel like in general procedural content generation is sort of beginning to stagnate a little bit as it's used repeatedly for the same things over and over again. Not so much in the big professional games that you see released on Steam or advertised on the TV or whatever, but maybe at the lower end of people making their first games, and part of the reason for that is that there's not much support for those people just getting into procedural generation. So widely available tools like Unity don't really have support for generative development. They're a little bit hostile towards writing procedural generators. And not everyone agrees with me on that. Obviously, you can download things from the asset store that make it easier, but Unity's core structure, lots of the tools that many people have access to and use, do not make it easy. In addition to this, procedural content generation tutorials often encourage people to sort of copy and paste code in without really understanding what it does, which is great because it allows them to use procedural generation. But without the deeper understanding of what the code is that they've copied, it's harder for them to experiment and tweak things and get what they actually want to happen in their game. They're sort of stuck often using templates that other people have made. These are obviously subjective views, and there are lots of great things going on in procedural content generation right now, and you're going to see lots of them this week. But I do feel like there are some issues there in the broader sense. So one of the things that that came out of this was me organizing a jam called PROCJAM, which I mentioned today earlier in the tutorial. This is the procedural generation jam. It's the third year that it's running this year. And the objective, one of the objectives behind the jam was to get new people into procedural generation, to provide tools for them, a welcoming environment, a nice community, to decentralize it from games and have artists and other people come in and share their ideas and their input, and to get lots of new ideas. And when I've been doing this, I've been thinking, what kind of support do these people need to get more out of the things that they're building? What kind of tools could we build them in the dream case scenario? I was also highly influenced by work by Gillian Smith and Jim Whitehead on a tool called Launchpad. Not Launchpad specifically, but some work that they did adjacent to it that's mentioned in some of the papers on something called Expressive Range. And Expressive Range is actually crucial to Danesh, and you're going to see it mentioned later on in the talk quite a bit. I'll just briefly explain to you what it is right now. So what you're looking at right now is a histogram. There are two axes. One is called linearity and one is called leniency. And these are two things that score some quality of a platformer level in this case, because that's what Launchpad was a tool that generated. So it's not important to know what linearity or leniency are necessarily, but just imagine that they're scores that each level has. And what Gillian and Jim did was they generated lots and lots and lots of levels, and for each level they scored the linearity and the leniency, and they made a note of the result. And each time a result fell in one of these grid squares, one of these hexes on the histogram, they increase that number. And what you see in the result is the more white an area is on the histogram, the more data points came on that particular area. So you can see over time, as you sample the generator more and more, you see roughly what the average statistics are for a level made with this generator, what the spread is across these statistics, and it's a really useful tool. And Gillian and Jim did lots of interesting research into this, like what metrics are useful to use, how do you visualize more than 2 metrics at once, and there are lots of open questions about this technique, but just the basic idea really grabbed me. I got really enthusiastic and motivated by it. So I began work on Danesh. Danesh is a Farsi word. It means knowledge. That's it written underneath the English there. And it is written as a Unity plugin. That might cause you to sigh. I've met an increasing number of people who are not keen on Unity. Some people ask me why I didn't write it as maybe for Unreal Engine or just as a standalone piece of software, like not linked to any engine at all, or any development tool, sorry. And the reason I built it for Unity, number one, is that I use Unity. I use Unity for everything, so it was just easier for me. I know that's a very lazy excuse to give, but at least it's honest. The other reason is that lots of other people use Unity, particularly people who want to make games. Maybe not so much first-timers. Lately I've been thinking that something for GameMaker would be very useful. But Unity was a nice trade-off between a tool that I was comfortable with and a tool that is used by lots of people to make games. So I built it as a plugin to the Unity generator. So what you're seeing here is the Danesh window as you would see it in Unity. It pops up as like another window, just like the lighting window or the window that you use to manage your assets. And I'm going to walk you through the various aspects of Danesh. We're going to go on a little journey together. I'm going to tell you a story of a procedural generator. And in all of these examples, we're going to be looking at this cave generator that you can see in the middle that produces these ugly two-tone color maps. I want you to imagine this is like a top-down view of a grid for like a roguelike game or something like that. So in the center, you can see the output of your generator. This assumes that you've loaded in your generator to Danesh. You've got this object in your game world with some code in. And the way Danesh finds your generator is it uses something called attributes in C#. So you put a little note above the piece of code that generates things, and you put the word generator in that attribute, and then Danesh can find it, and it can get the output from your generator and then visualize it. How it visualizes it, I'm just going to gloss over that, but it's in the paper. It's not as clever as it looks, and it's something that I need to develop in the future, but it's not important for this talk, so don't worry about it. The other thing that Danesh does is let you tag parameters. So you can see at the bottom here, I've also added attributes to parameters for this generator. And I've given it minimum values and maximum values, as well as a plain English name. And what that means is Danesh can give you little sliders where you can change the parameters, and then you can click generate content and see a new piece of content using these sliders. And so far this is pretty ordinary, and actually you can do all of this stuff just in Unity. Unity lets you modify parameters in real time and things like that. So there's nothing new here at all. This is just convenience. The other thing Danesh lets you do is define metrics. So metrics are kind of like the things that we saw in that expressive range example earlier for Julian Smith's expressive range kind of histogram. So a metric registers something, it scores something about your content, and it returns a number between 0 and 1. So a metric is a function that takes the output of your generator and returns a number that expresses some quality of that piece of content. So in the top left-hand corner, we can see a few metrics for this piece of content. There's connectedness, density, openness, and these are metrics that I've written for this particular generator, so they won't make sense for other generators necessarily. Maybe they might, depending on what you're generating. But what you can do now is click Generate Content, and you can see now the metrics update every time you click Go with new values for the different metrics. So you might be able to see, oh, as I click Generate Content 10 times, I see that all of the connectednesses are 0.98 or higher, which is really good because that means that the dungeons are well connected to each other. And you can fiddle with some parameters and then click Generate again and see if that changes the metrics. And this approximates what most game developers have told me they do when they're producing procedural generators. Some people don't use metrics, they just fiddle with the parameters, But most people go through this loop of changing numbers, pressing generate content, and seeing what the outcome is. So let's see if we can do something a bit more interesting. Let's look at this part of Danesh, which is an implementation of Gillian Smith's expressive range analysis. So here we can type in a number of samples and then ask Danesh to do an ER analysis. And it will use the metrics that we've written to act as the axes for the histogram. So you end up getting something like this. It doesn't look as pretty and beautiful as Jim and Gillian's work, but it does the job. So you get a more white pixel anywhere as more samples appear at that particular point. So you can see here that for this current generator, the openness is a little bit higher than 0.5 and the density is a little bit lower than 0.5. And there's a sort of a weak negative correlation. So if I tell you that, as the name implies, density is the amount of solid space in a level and openness is approximately the amount of open space, not exactly, but it's very similar, it makes sense that the more open a level is, the less dense it is. So it makes sense that there's a sort of negative correlation here. And another nice thing that Danesh can do is if you hover your cursor over one of these points, you can see a little preview of the content that was produced that gave those metric values. So if you want to know like what is the most extreme version that was generated here, what is the most extreme value for openness, you can hover over that value and see a preview of what it is. Now this is useful for seeing what your generator is currently doing. It's actually really useful. You get a really good idea for what it can do and what it can't do, what the limits of your generator are. But we want to go deeper than this. We want to do more than this. Instead of just knowing what your generator is currently doing, what we'd really like to know is the complete extent of what your generator can potentially do. So what we want to do is do a random expressive range analysis. So instead of just using the generator as it is now and taking like 200 samples and plotting them on this histogram, what a random expressive range analysis does is every time it takes a sample, it randomly changes the parameters to new values. And the result of that is that you get something that looks a bit like this. I've actually colored a section of this RERA to show you where we were previously, if you look here. This is really for the paper. I've actually taken this diagram from the paper, but you get the idea is that this is a much more broad picture of what the generator can do than what the standard expressive range analysis was. This one shows us that there's a wide spread of openness values that we can get depending on what parameters we choose. It shows you things like where the results are clustered. So you can see on the left-hand side there's a very dense wedge of white pixels where there's clearly more results in that area than there are on average elsewhere. It also shows you, even more importantly, where there are no results. So it makes sense that there's no way to get 100% openness and 100% density. In fact, that's kind of obvious in this case. But if we were using other metrics, it might be much more subtle, and so knowing that we can't maximize both metrics at once is actually a really useful result. It means that we don't have to sit down and spend half an hour changing parameters trying to get a particular outcome. So, random expressive range analysis shows you what you could potentially generate, which is really useful because now you know what kinds of things you can aim for and what kinds of things you can't aim for. So let's go back to Danesh and look at what we've got now. What we've now got is a tool where we can change parameters and look at the metric effects, but we can also get this idea of what impact that's having on what the generator is doing. We can perform expressive range analyses, we can watch and see where the generator, where the shape of the ERA is changing over time, whether we're moving in the right direction. If we want more open maps, how do we make it more open? Maybe we can turn down this parameter or turn up this other one. What impact does that have? So we can see the output of the generator, we can play with its parameters, we can go through this iterative loop of changing something, observing the results, making more changes, observing new results. But is that really the best case scenario? Is that the best way that we want to do? Because the problem is that this can be a very tedious process. So like I said, some developers that I've spoken to just change parameters and run the game. So that's like your basic way of tweaking a generator. Some developers will use statistical analysis on their generators, which is like very customized, very personal. It's a very useful way of doing it. It's not necessarily very visual, but the chances are if you are writing these statistical analyses, you know what you're doing anyway. Then maybe a little bit more easy to use is something like this, visualizing like we've done with the ERAs. But really, the problem with all of these processes, even the ones that use the visual RERAs and ERAs and all the histograms that I've just shown you, the problem is that all of these systems work on the basis that you are changing the inputs to this black box and you're hoping that it has an outcome that you like. And what will be much easier when we're working with procedural generators is if we could describe what we want the outcome to look like and have the tool find inputs that get us there. And that's where automatic optimization comes in. Because actually we already have a way of talking about the output of a procedural generator. That's what these metrics are for. They describe properties of the content that's been generated. So the user of Danesh could say, instead of here are the parameters I want, what does the generator do if I set the parameters? The user could say, here are the metrics I want to come out of my generator. How can I get it to do this? And ask Danesh to look for it. And that's what this bottom left-hand corner is in charge of. It's currently called auto-tuning. And the way it works is you select the parameters that you want Danesh to have control over. You select the metrics that you want to use to describe your output. And then you write in some values. So here we've said that we're going to allow it to change just 2 parameters, because you might not want it to change all of them. You might have decided that some need to be there for certain design reasons, or you don't want it to change too many things. And we've said that we want approximately 40% density and 40% openness. And what we end up with is we have a starting ERA. This is before we do any auto-tuning. And then Danesh does this magical automatic optimization process, and then afterwards when we perform another ERA, we find that we've actually managed to move our outcome. We've managed to move the position of the generator in the expressive range space. And this is a real example, by the way, of a before and an after. The red is the before and the green is the after. And you can see that it's definitely moved right down to 0.4, 0.4 on both axes. So how can we do this? How are we going to do this? Because what we want to do is we want to end up with a parameter set. We want Danesh to find a parameter set that gets the metric outputs on average that the users set. So we used 3 approaches in our tests. The first one was random search, where you randomly pick some parameter values and test each one. This is it sounds like a stupid baseline, but it was actually, as you'll see, not as stupid as it first seemed. We had a hill climbing, where you would initially generate a random parameter set, and then slowly make tiny adjustments to it based on whichever one produced the highest benefit. And if we found that we were at a local maxima, we restart, because all of our adjacent changes don't provide any benefit. And finally, an evolutionary search. So you have populations of parameter sets, and you do kind of a 1-point crossover on a parameter set when you want to, and sort of a bit of a mutation as well, where you change a particular parameter value. And other than that, it's a fairly standard evolutionary search. And like I said, lots of these details are in the paper. If you want to go more into the actual setup of each of these optimization techniques. So we had 3 tests. I have just noticed they're all labeled test 1. That is my bad. But there were 3 separate tests, and they all had different sets of parameters and target metrics. So the first one was relatively easy. We had 2 target parameters and 2 target metrics, and so on and so forth. And notice that adding more parameters can be both good and bad, because you're giving Danesh more opportunities to find good settings, but you're also providing it with more things that it has to try out and test. So there's also more useless results that it has to wade through. So the first test we did was, if there was only a certain amount of time available, what's the best fitness that each of these approaches can achieve when they run their experiment? So at 2.5 seconds, 5 seconds, 10 seconds, and 20 seconds, report the best fitness. And in this scenario, fitness means when you perform that expressive range analysis, you find the center, basically, of that cloud of data points, and you want to look at the distance between the center of that cloud and the metric values that the player supplied to us. And I won't go through all of these results because it's a boring table of data, but basically most algorithms end up with a relatively okay result. But some algorithms actually take a long time to get going, which makes sense because things like the evolutionary generator has to do maybe 15 or 20 sets of samplings before it can get one result because it has to process a whole population. Whereas the random search can instantly perform one check and then it has a baseline result. Like even if that's not a very good result, it has at least one result to give you. So we found that even though most approaches do fine if they're given enough time, for very, very quick results, there are actually issues. And we thought about what that meant, and we thought about what that might imply for Danesh and the kind of people that want to use it and the way they want to use it. And we did a second test, and we looked at fitness priority. So instead of looking at how much can be done in a certain time, we looked at how long does it take you to reach a certain quality of result. So we looked at 0.9 and 0.95 fitness. And the results for that were a bit different. When we found that actually these more, in quotation marks, sophisticated approaches actually generally do better than just the random search, particularly for quite complicated or intense tasks and quite high sets of fitness. But the overall feeling that we got is that although these approaches seem to be doing a bit better in if you want the best result possible, it feels like there's likely to be two classes of user for Danesh. Some users are going to want a result as quickly as possible. They're going to want it within a few seconds so they can continue making changes and continue tweaking. Whereas other users are going to be more laid back. They're going to be willing to run Danesh overnight. They're going to be willing to say, I'm going for lunch, here's an hour, optimize my generator, and I'm going to walk away. So we're thinking of hybrid approaches that combine some of these algorithms, but we're also thinking of just allowing the user to say, I need quick results or I need the best results, which is not an uncommon thing for tools to offer users. These results are pretty preliminary. We need a lot of work doing on this tool to nail down our methodology and feel confident in what we're doing. We also need maybe a better understanding of what a baseline test is. So in this case, we used a very regular generator. We wrote some fairly regular metrics, but our idea of what regular is not what everyone else's is. And ultimately, these are grid-based generators. Not everyone's making those. More complicated generators are probably going to challenge our approaches in a much more serious way, and it might be that Danesh is actually unusable for very complex generators. So we need an idea of what a good test actually looks like for these tools, but we do find that these results were promising at the very least. And as I said, neither time nor fitness seemed like an obvious priority, so it feels like there should be a trade-off between both of them, and we should offer both of them as options. In the future, we'd like to look more deeply at visualizing the output of ERAs. So things like allowing people to draw circles on the histogram to indicate where they want their optimization to end up, rather than typing in numbers, will be a lot more easier for people to grasp, we think, and a lot more usable. We also want to investigate parameter volatility. So we noticed that when the optimization was taking place, some parameters would have vast effects on the fitness of an automatic optimization, whereas other parameters were very steady and linear, and small changes could be made with small results. And we can actually get Danesh to assess how volatile a parameter is in advance by doing some preliminary testing. And we think that might help improve the results of the optimization if it knows how large an effect changing a parameter is likely to have. Finally, we're really interested in other ways of users expressing what they want from a procedural generator. Writing metrics is a very complicated task in Danesh right now. It requires a bit of expert level knowledge, which obviously defeats the object of having a tool that's accessible and usable. And so what we'd really like is for people to be able to give examples of the kinds of content they want generated and have Danesh optimized towards them. And we're very interested in the idea that machine learning could be employed here, and we're currently working with some other researchers to investigate this. Thanks very much for listening. If you want to learn more about PROCJAM, we've got some papers online at danesh.procjam.com, and there's also a link to the GitHub repo where the entire project is online for free. You can take in, you can look at all my awful code. It is designed to be modular. The idea was that you lovely people might download Danesh and make your own tab inside the tool for other people to use that uses your own research to help people understand their procedural generators better. It's not a perfect tool, it's far from it in fact, but we do think that it's important to help build more support tools and look towards the community more rather than focusing on whatever new system we've worked on lately. And as I said earlier today, please come and join in PROCJAM.com, engage with our community. We've got some really awesome talks on October the 21st. We'll be streaming them live on YouTube, so please tune in for those. And then the jam itself will be taking place in November. And you can come in and chill out with us and make something fun that uses procedural generation. Thanks very much for listening. Sorry that I wasn't there in person again, but I hope this talk's been okay. And if you want to chat with me, I'm on Twitter every hour of the day at MTRC if you want to chat about Danesh or anything else. Thanks very much for listening.